What is light?
An electromagnetic wave to which human eyes respond.
What is electrostatics?
Study of the causes of the attractive and repulsive forces, called static electricity, that result when objects made of two different materials are rubbed together.
How do optical fibers use total internal reflection to transmit information?
Strands of glass fiber, commonly known as optical fibers, use the principle of total internal reflection to transmit information near the speed of light. The fiber has an inner core of glass with a high refractive index surrounded by a cladding of glass with a lower index. A laser sends light into the end of a strand of fiber. When the light strikes the interface between the core and the cladding, the light is reflected back into the cable, continuing to move down the length of the fiber. Light or near-infrared radiation can travel kilometers through fibers without significant energy loss. One reason is the total internal reflection. The second reason is that are made from materials designed to absorb as little as possible of the infrared radiation. A second advantage of optical fibers is that information sent through the fibers is more secure, because it doesn't escape the fiber and thus be accessible to those trying to intercept the information.
What is a radar?
An acronym for radio detection and ranging.
What concerns did pilots and engineers have about breaking the sound barrier?
To reach the sound barrier in an airplane was a major goal for many in the aeronautical field. A goal that carried some uncertainties. Pilots and engineers alike wondered and feared what would happen to a plane's maneuverability when it broke through the shock wave, as well as what would happen to the plane itself, structurally. Near the end of the Second World War there were fighter planes that were very strong and had powerful engines and experienced pilots. A number of pilots died when their planes broke apart in mid-air, often when in dives. There were two problems with these aircraft. First, the wings were not swept back, and second, they were driven by propellers. As the shock wave forms near Mach 1, it bends backward from the nose of the plane, like a bow wave on a boat. If the shock wave encounters the wings, that is, the wing extends through the shock front, there are tremendous forces on the wings. In a supersonic plane the wing is always designed to be fully behind the shock front. Because the shock front can tear the wing off the plane. The propeller causes a pulsation in the pressure on the wing, every time one of the blades goes by. It produces a region of slightly higher pressure behind it, followed by a region of low pressure. All of these things came together and helped cause mid-air structural failures of the World War II fighter planes.
What is a good insulator of electrical charge?
In an insulator, the electrons are strongly bound to their nuclei and thus cannot move through the material. Good insulators are nonmetals, such as plastic, wood, stone, and glass. Your skin is a good insulator, unless it is wet.
What is matter?
Ancient people in many parts of the world believed that all matter was made of 4 elements: earth, air, water, and fire. No matter how small an amount of material you had, you could not separate an element into a combination of other materials.
What is the speed of sound?
In air, about 340 m/s or 760 miles per hour, at 20 degrees Celsius. Increases by 0.6 meters per second for every degree Celsius increase in temperature. V equals 331 m/s, 1 plus 0.6 T, where T is measured in Celsius.
What is a first-class lever?
Simple machine with pivot at one end or bar. The input force applied at the other end, the effort force between the two. Ma greater than 1.
How do traffic lights at car intersections know when a vehicle is present?
Many traffic lights are triggered to change by the approach of a car. The principle is similar to the metal detector, in that there are coils of current carrying wire just below the road where the vehicles stop at the intersection. When a large enough amount of metal passes over the coil, it induces a change in the current that creates a signal in the electronic circuits that control the traffic light.
How dark can it get on Earth during a solar eclipse?
Some observers reported that they saw Venus and some of the brighter stars during a total solar eclipse. It is not entirely dark, however, because light comes from the sun's corona. The extremely faint glow surrounding the sun that is produced by ionized gases emitted by the sun. More light may come from reflection of light by the atmosphere in nearby areas not in the path of totality. The complete eclipse of the Sun lasts for an average of about 2.5 minutes, but can last over 7 minutes.
How can energy be transferred?
Any energy transfer involves a source, whose energy is reduced. A means of transferring the energy, and an energy receiver, whose energy is increased. It's convenient to use a diagram to keep track of the source, the transfer, and the receiver, see pages 61 to 62. For example, if a moving pool ball collides with another ball, it can transfer all or part of its kinetic energy to the other ball. Transfer of energy by this kind of mechanical interaction is called work. The moving ball does work on the stationary ball and its kinetic energy is reduced. The kinetic energy of the stationary ball is increased by the work done on it. When a slingshot does work on the stone, its stored elastic energy decreases and the kinetic energy of the stone increases. When you throw a ball, your stored chemical energy is reduced. Work is done on the ball, and the ball's kinetic energy is increased. Other methods of transferring energy that do not involve work will be discussed later.
What is the modern conception of light?
As demonstrated by the work of Young, Poisson, and Fresnel, and later by James Clerk Maxwell, 1831 to 1879. And Heinrich Hertz, 1857 to 1894, light is an electromagnetic wave to which human eyes respond. It is located on the electromagnetic spectrum between infrared and ultraviolet. The limits of human vision define the lower and upper boundaries of light. The lowest frequency is 4x 1014 Hz, which has a wavelength of 700 nanometers, 700 x 10 to 9 m. Its upper boundary is 7.9 x 1014 Hz, a wavelength of 400 nanometers. Wavelength rather than frequency is commonly used when describing light because until the past 3 decades only wavelength measurements were possible. Light frequencies were too high to measure directly. Light has all the properties of a transverse wave. That is, it can transfer energy and momentum. It obeys the principle of superposition and can be diffracted and interfere with itself. On the other hand, it also has the properties of a massless particle. While in a medium it moves in a straight line at a constant velocity. It can transfer energy and momentum.
What is a watt?
A watt is the unit of power, or the rate of energy transfer. Light bulbs, toasters, hair dryers, televisions, and other electrical appliances are rated by the power they use. In the context of electricity, The watt is the unit for electrical power and is often found on light bulbs and other devices used in electrical circuits. The formula to find the power used is P equals I x Vt, power equals current times voltage.
How can temperature be controlled?
A device that maintains a constant temperature is called a thermostat. A traditional home thermostat contains a coiled bimetallic strip. When the temperature drops below a set point, the strip trips a switch that turns on the furnace. More modern home thermostats use an electronic thermometer and electronic circuits that turn the furnace and air conditioning system on and off.
What contribution did Thomas Edison make to the electric light?
The American inventor Thomas Alva Edison, 1847 to 1931. Tried literally hundreds of different materials as filaments for the lamp. He found that heating a cotton thread in the air left a thin length of almost pure carbon. The carbon filament was connected to wires sealed in a glass bulb from which the air was removed. In 1878 this first practical electric lamp lasted for hours more than any other lamp.
What are gears and why are they simple machines?
Gears are toothed wheels which transmit torque between two shafts. The teeth prevent them from slipping, so they are called positive drives. The smaller gear in a pair is called a pinion and the larger one a gear. Because the teeth mesh, in a given amount of time. The number of teeth engaged on the pinion equals the number on the gear. The number of teeth is proportional to the circumference of the gear that, in turn, is proportional to the radius of the wheel. Therefore if the pinion makes one turn, the gear will make, repinion/regear, turns. Because energy is conserved. The torque exerted by the gear equals the torque applied to the pinion, regear/repinion. Gears are often used in an automatic transmission, converting the high speed, small torque output of the engine to the low speed, large torque output needed to turn the wheels. This kind of gear drive is called a step-down drive. On the other hand, in a windmill, the blades turn at a low speed but provide a large amount of torque. The gear drive in a windmill is a step-up drive. The electric generator, on the other hand, requires high speed, but can work with a smaller amount of torque. Gears also allow a bicyclist to match the speed with which she can rotate the pedal sprocket with the speed needed to drive the wheels.
What is a gigahertz, GHz?
1000 million or 1 billion Hz.
What is an alpha decay?
Type of radioactive decay where nucleus emits an alpha particle. Result is nucleus with atomic number reduced by 2 and mass number reduced by 4.
How is antimatter used in medicine?
A three-dimensional image that shows biological activity in a person can be made using PET or positron emission tomography. PET uses a short-lived positron-emitting isotope, typically 11C, 13N, 15O, or 18F. The isotope is chemically attached to a molecule that is involved in the activity that is to be studied. Fluid containing that molecule is injected into the person and after enough time passes for the molecule to reach its target, the person is put into the PET machine. The positron that is emitted by the decaying nucleus strikes an electron and decays into two gammas that are simultaneously emitted back to back, that is, 180 degrees apart. Detectors record the arrival of the two gammas, and computers extrapolate them back to the location of the gamma emission. When a sufficient number of events are recorded, a three-dimensional image of the region where the biologically active molecule accumulated can be made. PET scans can be combined with CT or MRI scans to pair information on the anatomy with biological activity for diagnostic purposes.
What are transformers?
An impedance matching device is called a transformer. Instead of an abrupt change between the two media, a transformer provides a smoother, gradual transition from the old to the new medium. Depending upon the wave and the medium, different transformers, such as quarter wavelength and tapered transformers, can be used to help minimize reflection. An example of a tapered transformer can be found in soundproof rooms or sound studios. Any sound that is produced is supposed to be absorbed by the impedance matching material on the walls. Special foam, tapered in a V-like shape, is used as a transformer to gradually absorb all the sound into the walls. The gradual changeover from the air medium to the wall medium prevents sound from reflecting back into the air. An example of a quarter wavelength transformer can be found on many camera lenses and eyeglasses. The quarter wavelength thick coating on a lens is used to reduce reflections off the lens surface, allowing more light into the lens. Electrical transformers are also used to match impedances by changing the varying voltages and currents in an electronic circuit. Modern electronic circuits make very minimal use of transformers because of their weight and size.
What is a convex mirror?
Curved outward. The reflected light spreads out rather than converging at a point.
What is thermodynamics and statistical mechanics?
Studies how temperature affects matter and how heat is transferred. Thermodynamics deals with macroscopic objects. Statistical mechanics concerns the atomic and molecular motions of larger numbers of particles.
Are there other ways pulleys can be used?
Two or more pulleys, on fixed axles, can be connected together with a belt. If the two pulleys are of different diameters, then the one with the smaller diameter will turn faster, and thus it can exert a larger torque. In your automobile, one or more pulley and belt systems are used to deliver torques from the engine to the valve crankshaft. The water pump, the air conditioning compressor, and the alternator. Continuously variable automobile transmissions are used in a few modern cars to connect the engine to the drive shaft. The torque that can be delivered by an engine depends on the rotational speed. The torque is maximum at an intermediate speed. A transmission is designed to allow the engine to revolve at a speed where it can deliver torque to the drive shaft. The axle, and the wheels that are revolving at a variety of speeds. When the auto is accelerating from a stop, the wheel rotation speed is slow. And so the transmission needs to match a large diameter pulley attached to the engine to a smaller one connected to the drive shaft. On the other hand, when the auto is traveling at a high speed, the engine can revolve at the same or even a smaller rate than the drive shaft.
What is a pewter?
An alloy of tin with copper, bismuth, and antimony.
What is an induced drag?
A consequence of the lift generated by the wing. Induced drag causes vortices.
What is a qubit?
Qubit is short for quantum bit, the basic piece of information for a quantum computer. A qubit can be the state of an atom, ion, photon, or an electron. As was the case of the polarization of the two gammas, the qubit doesn't have a value of 0 or 1, but is in a state that is a superposition of 0 and 1, so it can have any value between those two numbers. If you try to measure the value of the qubit, you will get either 0 or 1. So it will act like a bit in a normal computer. The trick is to use one of two entangled photons, or atoms, to determine the qubit state without collapsing it into either 0 or 1. Quantum computers are by nature parallel machines that can work on many problems at once. At this time, computers with 12 qubits have been demonstrated. So there is a long way to go before such a device is practical. Still, progress is being made. A company has demonstrated a way of using the kind of chip lasers used in CD players to create entangled photons, greatly reducing the size, complexity, and cost of a quantum computer.
How do one-way mirrors, the ones used in interrogation rooms, work?
A one-way mirror seems to be a mirror when seen from one side, but as a window when seen from the opposite side. Thus the window is disguised as a mirror to allow secret surveillance. Physically, there is no such thing as a one-way mirror. That is, the amount of light reflected from one side is the same as that reflected from the other. The light transmitted in one direction is equal that transmitted in the opposite direction.
What factors determine the amount of resistance of a conductor?
The resistance of a wire or other conductor depends upon the following. The length of the conductor, the longer the wire, the more resistance. The cross-sectional area of the conductor, the thinner, the more resistance. The properties of the material, for metals, the fewer the number of free electrons, the more resistance. The temperature of the conductor, for metals, the warmer. The more resistance, for carbon the cooler, the more resistance.
Why was plutonium used in bombs?
Plutonium is not found in nature, but it is produced in reactors by bombarding uranium-238 with neutrons. Plutonium-239, 239Pu, can be fissioned by slow neutrons, and so could be used in weapons. In December 1942, Hanford, Oregon, was chosen as a site for reactors that would produce plutonium. Hanford was selected because it was isolated but also on the Columbia River, which afforded a source of cooling water.
Are there problems with Rutherford's model?
Electrons moving in circular orbits are experiencing centripetal acceleration. All accelerating charges radiate energy. As a result, the electrons in Rutherford's atom would lose all their energy in a tiny fraction of a second.
What is fluid dynamics?
Fluid dynamics is the study of fluids in motion.
What would happen if the table were replaced with a sheet of paper?
The paper might hold small stones. But with a heavy rock it would tear because it could not exert a strong enough force. The heavier the rock, the greater the force the table or floor exerts. In summary, inanimate objects can also exert forces. Forces like these, exerted by humans or tables that touch the object, are called contact forces.
What is the diffraction of light?
Reflection and refraction use the ray model of light. But, when light goes through a very small opening, the ray model is no longer sufficient. The wave properties of light become important. Suppose you pass light through a round aperture whose diameter you can change. Let the light fall on a screen. As you first begin reducing the size of the hole, you'll find the size of the bright spot shrinking. But, when the hole becomes very small, a strange thing happens. The spot no longer shrinks, but its outer edge becomes fuzzy. Light begins to bend around the edge of the hole. Diffraction also occurs when light is sent through narrow slits or if there are small objects that cast shadows in a broader beam of light. Diffraction occurs with all types of waves. You can often see it in water waves, and it is one reason that sound waves spread when they come through a door or window.
What is radar?
Radar is an acronym for radio detection and ranging. A radar installation emits electromagnetic waves and detects the waves reflected from an object. It measures the time for the echo to return to find the distance of the object. The radar dish is constantly rotating, permitting it to find the direction of the object as well. Radar is used in many different arenas, but was first used in World War II to detect the approach of enemy bombers.
Is there a net force on a polarized object? And can it exert a net force on the charged object, like the cellophane tape?
Yes, because the electrostatic force is stronger at closer distances. Thus the attractive force between the unlike charges is stronger than the repulsive force between the like charges, and there is a net attractive force.
How much does a moving clock slow down?
A clock on a jet plane, V equals 550 miles per hour, would lose 0.9 milliseconds per year. while one in the Space Shuttle, v equals 17,500 miles per hour, would lose 0.9 s/year. In 1971 atomic clocks were placed on planes, one of which flew around the world eastbound, the other westbound. The changes in time were measured and agreed with relativity theory. Clocks on GPS satellites must be adjusted for the loss of time. More conclusive tests have been done with very fast-moving, 0.995 c, muons. Muons, when at rest, decay in 2.2 ps, microseconds. The number of muons, produced high in Earth's atmosphere by cosmic rays, were measured at the peak and base of a high mountain. The ratio of numbers at the two heights showed that the muons lived 22 ps, which agreed with their measured speed of 0.995 c. From the viewpoint of the muons, they decayed in 2.2 ps. But the height of the mountain was 10 times shorter than that measured by observers on Earth. Thus the predictions of slower clocks and shorter distances have been tested and agree with Einstein's predictions.
What is a resistance, R?
Friction that electrons encounter due to collisions with the atoms in a wire causes electric charges to lose electrical energy, equal to potential difference divided by current.
How was electricity used as a form of entertainment?
In the mid-1700s, demonstrations of electrostatics were extremely popular, especially in Parisian salons, where wealthy men and women gathered to discuss events of the day. Benjamin Franklin, 1706 to 1790, was a popular guest in Stephen Gray's most famous demonstration, called the Flying Boy Experiment. A boy was suspended horizontally using two silk threads hung from hooks placed on the ceiling. When a charged tube was held near his foot, pieces of metal foil were attracted to his face and to his outstretched hands. Louis Guillaume Le Monnier discharged a Leyden jar through a chain of 140 courtiers in the presence of the King of France. Jean-Antoine Nollet, 1700 to 1770, attempted to measure the speed of electricity by having a line of monks 1 kilometer, 3,280 feet, long hold hands. The monks at the ends of the line touched a machine that produced charge. They all jumped simultaneously when they felt the painful shock. So he concluded that electricity moved instantaneously.
What is an entanglement?
An effect in an atom or nucleus when 2 or 3 photons are emitted. The spin of one photon depends on that of the other, or is entangled with it. Measuring one spin tells you what the direction of the other is.
What is reflection?
Light or other wave bounces off a surface or interface between two media.
What is a rarefaction?
Region of lower pressure in a longitudinal wave.
What is ultrasound?
Ultrasound is a method of looking inside a person's body to examine tissue-based and liquid-based organs and systems without physically entering the body. Ultrasound systems direct high-frequency sound, usually between 5 and 7 MHz, into particular regions of the body, and measure the time it takes for the sound wave to reflect back to the machine. By analyzing the pattern of reflections received, a computer can create a visual representation of the interior of the body. Dolphins can detect frequencies of between 110 and 130,000 Hz. Their hearing is over 6 times more sensitive than that of a human being. Ultrasound is sometimes used instead of X-rays because it does not use ionizing radiation and thus is safer for the person being examined. Obstetricians use ultrasound to examine the progress and/or problems that a fetus might be experiencing. Ultrasound is also used to observe different fluid-like organs and systems in the body such as the nervous, circulatory, urinary, and reproductive systems. Ultrasound can also be used to pulverize kidney stones. In this application, very intense, tightly focused beams of high-frequency sound are directed at the stone. The stones are shattered and the small pieces can be passed through the urinary tract with little or no pain.
Why are electromagnets, the kind that pick up junk cars, so strong?
An electromagnet is a coil of current-carrying wire wound on an iron core that is at the center of an iron cup. The magnetic field created by current in the wire is strengthened by the iron core. The strength of the magnetic field produced by such electromagnets creates a large force, as described by the Lorentz force law, that allows people to more easily move large metal objects, such as steel cars, from one location to another.
What are the strengths and weaknesses of nuclear power?
Electric power is produced primarily by plants using hydrocarbon fuels, coal, oil, and natural gas. These are usually called fossil fuels and are no longer being created. When they are used up, these resources are gone. Nuclear power plants can reduce our reliance on such fuels. Uranium, however, is also a fossil fuel. Coal mining has significant environmental costs. Oil is used mostly for transportation. Natural gas is relatively clean and is used mostly for home and industrial heating. Another advantage of nuclear power is the reduction in greenhouse gases, primarily carbon dioxide. One major disadvantage of nuclear power is the cost of the plant and the extremely long time scale associated with obtaining approval and constructing the facility. Costs are difficult to calculate precisely, but nuclear power and offshore wind farms are the two most expensive methods of generating electricity, while oil from the Middle East is the cheapest. As a result of these uncertainties, factors other than costs are increasingly important. Other disadvantages include the production of nuclear waste that poses long-term dangers to people due to its intense radioactivity. No long-term storage plans have been proved. Although underground storage in salt deposits is the most likely method.
How much does a sound's intensity diminish as you move away?
When the total energy in the sound wave remains the same as the sound spreads over a sphere, the intensity decreases as the area of the sphere increases. The area of a sphere is proportional to the square of its radius. So the intensity is inversely proportional to the square of the distance. That is, sound intensity diminishes according to the inverse square law. For example, if a person stands 1 meter, 3.3 feet, away from a source, the sound intensity might be an arbitrary unit of 1. If that same person moved so she was 2 meters, 6.6 feet, away from the source, the intensity would be 1 over the square of the distance, or again 1/4 the intensity. Again, if the listener moved 3 meters, 9.8 feet, away, the intensity would be 1/9 it was at the 1 meter mark.
How are neutrinos detected?
Neutrinos hardly interact at all with matter. Some 100 trillion pass through your body every second. Yet the chance that one interacts in your body over your lifetime is only 1 in 4. For this reason, neutrino detectors must be huge and can expect to detect only an extremely small fraction of the neutrinos striking them. Most detectors are large cavities filled with extremely pure water or mineral oil. Neutrino interactions result in flashes of light that are seen by sensitive phototubes. The detectors have identified neutrinos from the Sun, from cosmic rays, a supernova, and from reactors and particle detectors. Some experiments have used beams of neutrinos that are aimed through Earth by a reactor or accelerator at a distant detector.
What are cathode rays?
Electron beam in an evacuated glass tube.
Why do most color inkjet printers use 4 colors to print, instead of the 3 primary colors for subtractive color mixing?
It would seem that a color inkjet printer mixing the 3 primary pigments of yellow, magenta, and cyan should be able to produce all the other colors, including black. When all 3 primary colors are combined, however, the mix looks more like a muddy brown color than black. Although these are the primary colors of which other shades can be created, they do not represent all the colors of the spectrum needed to form black. That is, there are gaps in the wavelengths that these pigments absorb. Therefore, most color inkjet printers have a cartridge with yellow, cyan, and magenta ink, and another separate ink cartridge of just black.
What is a stealth plane?
Stealth aircraft are planes that are able to avoid radar detection. The materials on the plane's surfaces and their peculiar shapes and angles deflect radar waves away from the plane. Or in some instances, the plane's outer fuselage can actually absorb the radar waves without reflecting it back to the enemy radar transmitter. Refer to the Fluids chapter for more information about aerodynamics and aviation.
What are force carriers?
The photon is called the force carrier for the electromagnetic interaction. That means that, for example, the attractive force between 2 oppositely charged objects is described mathematically not by an electric field, but by an exchange of invisible photons. The photon has neither mass nor charge, but does have angular momentum. The gluon carries the color force which, in combination with quarks, creates the strong force. The gluon also has neither mass nor charge. The weak nuclear force is carried by the massive W+, W', and Z degree particles. Gravity is carried by a massless particle called the graviton.
What is aerodynamics?
Aerodynamics is an aspect of fluid dynamics dealing specifically with the movement of air and other gases. Engineers studying aerodynamics analyze the flow of gases over and through automobiles, airplanes, golf balls, and other objects that move through air. They also study the effect of moving air on buildings, bridges, and other static objects.
What is a nuclear reactor?
Method of producing electric power where energy released by nuclear fission is used to boil water, producing steam that turns generators.
What is the Système International, SI?
The International System of Units. Based on the meter kilogram second, MKS, or metric system.
What is a laser?
Light source using stimulated emission of radiation invented in 1960 creates tiny spot of very intense, monochromatic light.
What is a neutron?
Unchanged arged particle in nucleus with mass slightly larger than that of the proton.
What is an alternating current, AC?
Polarity of the voltage source and thus current changes back and forth at a regular rate.
Does the gravitational force also obey Newton's third law? How?
All objects have gravitational fields surrounding them. So, just as the moon has a force exerted on it due to Earth's gravitational field, Earth has a force on it due to the moon's field. As a result, the moon does not orbit around Earth's center. But the moon and Earth orbit around a point roughly 2,900 kilometers from Earth's center. The Sun and other planets also exert gravitational forces on Earth, and Earth does on them. The gravitational fields of the planets, in particular Jupiter, cause the Sun to orbit around a point near its surface. Thus, if an observer on another planetary system studied the motion of the Sun carefully, he or she could determine that planets were orbiting the Sun. This method has been used to detect well over 200 planets, called exoplanets, or planetary systems, and other stars.
What is a sonar?
Acronym for sound navigation and ranging. A method of using sound waves to determine the distance between an object and a sound transmitter.
What is a superconductor?
Allow electrical current to travel without resistance, and therefore no voltage drop across them or energy loss.
How can athletes use angular momentum?
Let's explore two different sports. In platform diving, a person pushes off the tower, and thus the platform exerts a force on her, Newton's third law. But, if she isn't standing straight up, the force also exerts a torque on her, and starts her rotating. If she pulls her arms and legs in, then her mass is closer to her axis of rotation, and her speed of rotation increases. To slow this rotation, she can extend her arms and legs. With good timing, she can hit the water with a bare minimum of rotation. Consider a figure skater. She can start spinning on the point of one skate by pushing on the ice with the second skate. Again, the force of the ice exerts a torque, and so her rotational speed increases. She can extend her arms to slow the rotation, or pull them in as close as possible to attain the highest spin rate.
How is surfing a lot like downhill skiing? How can they be similar?
Surfing is done on water, skiing on snow. The main similarity is that in both cases the athlete and board travel down a hill. In skiing, the hill is a mountain covered with snow, while in surfing the hill is the rising water of a breaking ocean wave. An ideal surfing wave has a large amplitude as it reaches an extremely gradual decrease in ocean depth. While the surfer moves down the wave, the water on the front edge of a crest continually rises underneath the surfer, allowing the surfer to ride down the wave without actually moving downward. Some of the best surfing is done on Waikiki Beach on Oahu in the summer and the north shores of Oahu and Kauai in Hawaii in the winter. In the continental United States, the best surfing is in Southern California. The Pacific Ocean, famous for its long wavelengths and gradual decreasing depth beaches, has some of the best surfing in the world.
Who determined that sound needs a medium through which to travel?
In the 1660s, English scientist Robert Boyle, 1627 to 1691, proved that sound waves need to travel through a medium in order to transmit sound. Boyle placed a bell inside a vacuum and showed that as the air was evacuated from the chamber, the sound of the bell became softer and softer, until there was no sound.
What is an electrical conductor?
A material that allows electrons to move easily through it.
How far will it rise?
As some of the wood rises above the level of the water, the volume and the mass, and therefore the weight, of the water displaced will be reduced. When the weight of the wood and the weight of the water displaced are equal, the net force on the wood will be zero and it will no longer move.
Why do we need to introduce momentum and energy? Aren't Newton's laws good enough?
Newton's laws could be used, but when you analyze the motion of more than a few interacting objects, Newton's laws are just too complicated. When you use momentum and energy, you concentrate on the beginning and end of an interaction, not on the details of the interaction. A sports team can be said to have momentum.
What are other uses for microwaves besides communication?
In addition to having a great range of frequencies to transmit information, microwaves are used every day in kitchens around the world. Microwave ovens generate 2.4 GHz waves and scatter them throughout the oven. The microwaves excite water and fat molecules into resonance and cause them to rotate, increasing their thermal energy. Different kinds of molecules absorb the energy at different rates, so some foods are heated more than others. Microwave-safe containers are made of materials that do not absorb microwave energy and so remain cool.
What is the Bohr model?
A nuclear model, but with electrons moving in only certain allowed orbits at discrete radii and with specific energies. When in these orbits, their radii and energies are constant, the atoms do not emit or absorb radiation. Electrons gain or lose energy when they jump from one allowed orbit to another. Then they emit or absorb light with a frequency given by hf equals E2. E1, where E2 and E1 are the energies of the electrons in the allowed orbits.
What is a parallel circuit?
A parallel circuit allows the charges to flow through different branches. For example, the wire from the battery would be connected to one terminal of each of 3 bulbs. The other terminals are connected together and to the negative terminal of the battery. The charges now have 3 separate paths through which they can flow. If one bulb burns out or is removed from the socket, that bulb would no longer light. But the current through the other 2 lamps would not change. They would continue to glow.
Why does sound diminish as you move farther from the source?
Sound waves do not travel in a narrow path, but spread out into the surrounding medium as spherical waves. As long as the energy in the sound doesn't change, the power per unit area decreases as the area increases. In some cases, there is some transfer of the sound's energy into thermal energy of the medium. Thus, there can be some loss of sound energy with distance, but this loss is usually small.
What is bronze?
An alloy of copper and tin.
What is a kilocalorie, kcal or cal?
The food calorie used to measure energy content in foods.
What is indigo?
Indigo is the color between blue and violet in the spectrum, but almost no one can distinguish that color.
How is light detected?
Light carries energy, so a light detector must convert light energy to another form of energy. In most cases, light is converted into electrical energy. In the eye, which will be discussed more thoroughly later in this chapter, light strikes a molecule called an opsin. The absorption of light changes the shape of the molecule, which results in an electrical signal sent on the optic nerve. In detectors used in digital cameras when light is absorbed. In a semiconductor, one or more electrons are released. The charge they carry produces a voltage that is then converted into a digital signal. In photographic film, molecules consisting of silver and chlorine, bromine, or iodine are used. When light strikes these molecules, it transfers its energy to electrons. The molecules are broken apart and a tiny crystal of metallic silver remains.
What is a Higgs particle?
Hypothesized particle associated with the mechanism that gives rise to the masses of the quarks, leptons, and the two weak interaction bosons, the W and Z.
What do some of the metric prefixes represent?
Prefixes in the metric system are used to denote powers of 10. The value of the exponent next to the number 10 represents the number of places the decimal should be moved to the right. If the number is positive, or to the left, if the number is negative. The following is a list of prefixes commonly used in the metric system. Sundials are a very old way to tell time. While accurate, they are limited by the fact that they only work when the sun is shining.
How long does it take light to travel certain distances?
The table below lists some travel times for light. Some of the destinations above would require light to travel in a circular or curved path, which it does not do.
Why are many water towers placed on high towers?
The height of the water determines the pressure. Since a holding tank is up high, it places a lot of pressure on the water in the rest of the water network. The tank should be as large across as possible so that for the same amount of water the vertical dimension of the tank can be as small as practicable. This design limits the variation in pressure as the tank empties or is filled.
How can a machine with a mechanical advantage less than or equal to 1 be useful?
If a simple machine has a mechanical advantage less than 1, then you exert a larger force on it than it puts on whatever object it contacts. The output force is less than the input force.
What is drag?
Drag is a force that opposes the motion of an object through a fluid. An object is often said to be aerodynamic when its drag forces are kept to a minimum. There are two types of drag on an airplane, parasitic and induced. Parasitic drag is the force when an airplane wing, automobile, or any other object moves through a fluid. The amount of drag depends on the density of the fluid, the square of the speed of the object, the cross-sectional area of the object, and its shape. A large fuselage, like that of a 747, has more drag than a small fighter airplane. A teardrop-shaped object has less drag than a rectangular block. A parachute is designed to have a high drag. Induced drag is a consequence of the lift generated by the wing. It is a function of the angle of attack of the wing. The lower the angle of attack, the smaller the induced drag. It occurs at the outer edge of the wing where the downward motion of the air caused by the wing meets the undisturbed air next to it. Induced drag causes vortices, the spiral motion of air that can be extremely dangerous to planes flying behind or below. Induced drag can be reduced by putting small, tilted surfaces on the wing tips.
What kind of forces can you exert on an object?
Hold a book in your two hands. What kind of forces can you exert on it? You could pull on the book to try to make it longer, or you push it to try to make it shorter. The name for the force on the book that pulls on it is a tension force, while the name for the force that pushes on it is a compressive force. You could also try to twist it, applying what is called a torsional force. Finally, place one hand on the front cover and the other hand on the back cover. Now push one hand to the right and the other to the left. This places a shear force on the book. Tension forces are common. If you hang from a chin-up bar, your arms experience a tension force. Pulling on a rope, wire, or cable also exerts tension on them. Materials experiencing tension will stretch some more and some less. Materials that stretch easily are called pliant, those that do not are called rigid. Scientists have measured the response of materials to tension and compression. The ratio of the applied pressure, called stress, to the change in length divided by the original length, called strain, is called Young's modulus. Its value varies from 10 Gn/m to 10 billion newtons per square meter. In wood to 200 Gn/m2 in steel and cast iron. That means that for an equal force on it, steel will stretch, or compress, 1/20th as much as wood. If you would hang a 120 kilogram, 264 pound, ball from a 6 meter, 19.7 feet. long steel cable 2.5 millimeters, 0.9 inches, in diameter, it would stretch 7 millimeters, 0.3 inches. In the case of the cable above, when you remove the weight, the cable will return to its original length. It is called an elastic material. If you exert a much larger force, the cable will not return to its original length. This is called the plastic region. At some point it will break. The force that breaks it is called the tensile strength. For steel, the tensile strength is 1 Gn/m2. Thus for cable in the example above, it would take a hanging mass of 500 kilograms, 1,100 pounds, to break the cable. Young's modulus also describes the change in length of an object when a compressive force is exerted on it. When you stand, you exert a compressive force on your leg bones and they will shrink somewhat in length. But a 70 kilogram, 154 pound, person standing on one leg will compress it by only 0.01% of its length. The Young's modulus for cartilage, the material between the bones in all parts of your body, is 1/10,000th as large as that of bone. So putting the weight of a 70 kilogram, 154 pound mass on a piece of cartilage with same area as the femur in your leg would compress it by 10% of its original thickness. For compressive forces there is a compressive strength. But, many materials will buckle if too great a compressive force is placed on it. Brittle materials will, on the other hand, break. The compressive and tensile strength of bones is almost exactly the same.
What is the difference between transparent and translucent?
Transparent media such as air, water, glass, and clear plastic allow light to pass through the material. Rays of light are either not bent or closely spaced rays are bent together. Translucent materials, on the other hand, allow light to pass through, but bend closely spaced rays into different directions. For example, frosted glass and thin paper are translucent because they let light through, but are not transparent because you cannot see clearly through them.